Thank you everyone for being here today. This is the first edition of the Certain Matching Microfinance virtual seminar series of this fall. We are very happy today to have Randall Wright from the University of Wisconsin present the paper Intermediaries, Inventories, and Endogenous Dynamics in Frictional Markets. Randy, please take over.
Okay, thank you, Bruno. You've seen the title page and you've heard Bruno introduce it. Hello to my co-authors who are out there zooming. So the goal is to study dynamic equilibrium and search-based models of, well, we're going to focus on models of inventories, and in particular, models of intermediate trade. Of the many applications of search theory to labor markets, marriage markets, monetary theory, over-the-counter markets, etc., this is a perhaps underappreciated application. Going back to Rubinstein-Walensky, they say that middlemen or intermediaries in the exchange process are a feature of most, if not all markets, almost all markets. And yet there's no role for that in general equilibrium theory, obviously. Similar to the way there's no role for unemployment or money and a variety of other things in general equilibrium. So they weren't that up to speed on search models. They kind of reinvented some things that other people were using, but put it towards a different application, trying to get middlemen to emerge endogenously. The key extension here, well, a couple of things. One is we're going to use some more interesting mathematics. It's not totally standard to some people, but to others it is. The thing about dynamics. And in terms of substantive features, we're going to have heterogeneous valuations. This is absolutely key for what we want to do, both in terms of economics and mathematics. And I'll say why later. Also, it's important to note that there's at least two branches of the Middlemen literature. There's work following Rubinstein and Walensky, which typically is thought of as applying to goods markets. And of course, there's Duffy, Garland, and Pedersen, who have dealers, which are typically thought as applying more to asset markets. But this is a general approach. It could be interpreted either as assets or goods being traded, or as inputs. For example, used capital. Here's some results. Due to heterogeneous valuations for the good being traded, or the input or the asset being traded, combined with entry decisions of a certain type, so a participation endogeneity, we're getting a multiplicity of steady states. And the intuition is pretty clear, although only once you know it. If agents using reservation, in particular middlemen, are using reservation strategies, as they will, quite generally, to decide when to trade, they're going to have a critical valuation above which they'll trade and below which they won't. But that critical valuation, the reservation value, is endogenous. If they lower their reservation value, they're going to trade more frequently. This means middlemen have to replenish their inventories more often. This is going to encourage seller entry. If there's lots of sellers, it's relatively easy to replenish your inventories. So middlemen are going to have a low reservation value. The market's going to be liquid. There's a lot of trade, hence there's a lot of entry. Given a lot of entry, there's a lot of trade. At the same time, if middlemen are very picky and choose a high reservation value, then typically middlemen do not need to replenish their inventories as often. This makes it harder for sellers to trade. There's less entry, rationalizing middlemen's choice of being picky. So there's multiple steady states that can emerge. It's not due to increasing returns in the matching or production functions. It's well known how to do multiplicity and dynamics in models with increasing returns. So Diamond and Fudenberg, Mortensen, etc. It's not due to monetary considerations. So in monetary models, there's multiple equilibria and endogenous dynamics. The intuition there is somewhat different, maybe even simpler. What you accept in exchange depends what other people are accepting in exchange. So it's not that. It's about this complementarity between reservation strategies and market participation. Going beyond steady state, we show endogenous fluctuations are possible. And in particular, we use bifurcation theory. Some papers, I have a paper with Ed Nozel and Linda Wong and Jet, which has a related multiplicity, but it doesn't work very well. Maybe I'll explain that as we proceed. We're going to use bifurcation theory to get endogenous cycles in continuous time. This is important. It's actually relatively easy to get dynamics in discrete time models, but sometimes those models depend critically on the length of a period. As the period shrinks, not only as you get to zero, but get below some strictly positive bound in terms of the length of the period, those discrete time cycles vanish. Our cycles do not vanish, they exist in continuous time. So that's somewhat different. It's an example of how discrete and continuous time make a difference. Okay. Here's the environment. Continuous time, there's three types of agents. They're ex ante exogenous, but participation will be endogenous. This is different from some papers. Farabuti and various co-authors, for example, have a version where agents are ex ante homogeneous and some sort become agents that kind of look like middlemen. That's not what's going on in most of the literature following Rubinstein-Wolinsky. There are these agents called buyers. They like to consume an object. There's agents called sellers. They can produce or are endowed with the object. And these are dedicated buyers and sellers. Then there's third parties. They neither consume nor produce the object in question, but in principle, they could buy from sellers and sell to buyers. The agents are infinitely live. That's not important. Risk neutral. That can be relaxed, but we don't relax it here. There's one indivisible object. It's called a good in this slide, but as I said, it could be an asset or an input. Let's call it X. Trade occurs in pairwise meetings. And let's assume S can produce this good at zero cost. That's not a big deal. It's almost a normalization. In particular, it's known in some of these papers that you can have a production cost, an entry cost, a one-time entry cost, or a flow entry cost. It doesn't really matter for some issues. So we're just going to assume the production cost is zero, but sellers are going to pay a participation cost. Here's a critical difference from some earlier work. Buyers receive a match-specific payoff, let's call it pi, from consuming the good X, and it's drawn from some distribution. This is going to be interesting for what we do. Okay, we're doing search theory along the lines of Diamond, or his early work where inventories were 0, 1. You can only store 1 unit or 0 units. And that's true of Duffy, Garland, Old Patterson. That's true of Rubinstein-Wolinsky, Kiyotaki, Wright, Burnett, Cole, Scheimer, Smith. All these models typically assume, for example, in the general Pissarides model or the textbook Pissarides model, firms can only hire 1 worker. So that can be generalized at a cost in terms of complexity. That's true here as well. So we're going to go with the baseline case where inventories are 0, 1. Now, to distinguish between assets and goods, this is not critical for anything we do, but it's a good way to keep track of results. There's a flow payoff to holding this object X. So Middlemen can hold it. If rho is positive, it's like a dividend, it's like a Lucas tree. So this model covers trade and assets. X could be negative, so that's more like a storage cost, which you'll see in models of, say, commodity money or retail markets where you have to pay some cost to keep your inventories fresh. Inventories depreciate at some exogenous rate delta. So the Poisson arrivals, it's a 3-sided market where middlemen, buyers, and sellers are all meeting each other. We're going to assume they meet according to this matching function or meeting function, which I like to call uniform random matching. Kirker and Nico call it the Kiyotaki-Wright matching function. I kind of prefer that, but maybe not everybody does. So there's a Poisson arrival rate alpha. Each meeting is a random draw from the population. So in particular, the arrival rate of meeting a buyer is some baseline arrival rate alpha times the fraction of buyers in the market. So this kind of rules out the original Rubinstein-Wolinsky specification. There's ways to get that back, but the original Rubinstein-Wolinsky specification had these agents who were potentially middlemen. They would buy from sellers and sell to buyers if and only if the middleman could meet a consumer faster than the producer could meet a consumer. So the endogenous advantage that middlemen have in that paper, in that literature, is in search. The literature proceeded to consider other types of comparative advantage. E. Ting Lee and Gary Biglaser have a variety of papers where middlemen have comparative advantage in terms of private information. That is to say, they can recognize good quality. So if the model has objects being traded that could be lemons, middlemen are better at identifying quality. Shevchenko and some others like Watanabe have versions where middlemen can hold bigger or more diverse inventories. There has to be some reason for middlemen to have a comparative advantage in order to be active in equilibrium. Could also be they just have higher bargaining power, which is an example of middlemen not doing anything necessarily productive, but engaging in rent-seeking behavior. There's an old issue in thinking about middlemen. Do they actually contribute to social value, or do they just profit from buying low and selling high? Well, it's known in this literature. It depends on details like parameter values. Okay, so that's the matching function. By the way, in the work I'm doing recently with Grace Kahn and Ziki, we're doing, it was in Grace's job market paper, where we swap out this three-sided market with two-sided markets. A wholesale market where middlemen and producers can trade, then a retail market where consumers participate, and they could buy from middlemen if they have the good, or they can buy direct from producers if producers choose to go there and try for a direct exchange. There's some big advantages to doing that. But we're working in this older tradition of a three-sided market. A problem with the three-sided market, it's not obvious how to generalize matching theory, or even just the meeting technology. Think about theory, don't think about theory. How do you do meetings in a three-sided market? You can do many things, but there's no, consensus way to model that. So the simple way to do it is this uniform random matchings, which we're going to do here. Okay. So trading protocol, let's see, there's some surpluses. So this is actually critical, I forgot to mention it. Various papers in the literature make different assumptions about market participation. The original Rubinstein-Walensky specification had middlemen staying in the market forever.
So right,
Yeah,
that's good. Just like I have going back in this slide. So just make sure I understood. So the difference, what the middleman can do here, and why they is because they can store the asset. Is that it?
yep. That's not
Compared
critical
to
because we can imagine producers is producing and storing the asset as well.
Mhm.
The advantage of middlemen, well, it's going to be a few different things. They could have high bargaining power. In general, they could have low research costs or storage costs. So we'll come back to that.
So you can store, and then you also change the search, right? Like, because if
Yeah,
the
in our
producer
setup,
can
they do not have
store,
an
he's
advantage in
still
search.
reach.
Everybody has the same search technology, uniform random matching.
Okay.
It's actually kind of tricky endogenizing search intensity. Several papers do it. So we're going to assume everybody has the same matching technology, and the middleman will operate if some other parameters are in their favor, such as bargaining power.
Okay.
We'll come back to this as we proceed.
Okay. Just to
So
make sure everybody
everybody, as I was
understands
trying
it,
to
everybody
say,
can
go
just
ahead,
to say
Vern.
like anyone who wants to ask a question, please feel free to interrupt it like a regular seminar. I should have said that this in the
Oh
beginning.
yeah, for sure. Okay, so it's important for tractability, but not for the substantive issues quite often. How long people stay in the market. As I was saying, Rubinstein-Walensky middlemen are in the market forever, repeatedly buying and selling. But buyers and sellers are only in it for one trade. When sellers sell, either to a middleman or to a consumer, they exit. Once consumers or buyers purchase the good, either from a seller or a middleman, they get some payoff and they exit the market. It's actually easier to have buyers and sellers stay forever. For buyers, it's not actually important. In these models, buyers are basically mechanical. But it's easier to have sellers stay in the market forever. Actually, here it is actually important to have buyers stay forever too, but only in terms of tractability. So the point of that is if buyers and sellers stay forever, that when a buyer meets a seller, they draw some valuation for the buyer, pi. And as long as that's positive, they may as well trade. They will trade. Inversions where agents exit after one trade, that's not so obvious because, there's the opportunity cost of future trade. But here, basically, we're not that interested in buyer-seller trade. We're interested in middleman trade. So we just assume buyers and sellers, whenever they meet, as long as this valuation is positive, they will trade. Now, it's different when a middleman meets a seller. The seller has some opportunity cost of trading. So the value functions to anticipate notation. V1, that's the value function for a middleman with 1 unit in inventory. V0 is the value function for a middleman with 0 units. The difference, it's like a capital gain middlemen get when they acquire inventory and a capital loss they suffer when giving up inventory. So that's going to be endogenous. Basically, exogenous, the buyers and sellers trade, all the action occurs in middleman trade. In particular, if the middleman meets the consumer and they draw a low value of pi, the random valuation, then they may decide not to trade. At some price, they will trade. Middlemen will always give up the good, but the buyer is not willing to pay a price, so there's really no gains from trade. By the way, we assume transferable utility here, so anytime the total surplus is positive in a meeting, 2 agents will trade. So here's the bargaining power when type I trades with type J. Doesn't matter much, I think, whether we do a particular type of bargaining like Nash or something else like strategic bargaining, but we'll come back to that soon.
Hey, Randy, I have a
Okay.
question.
Louder.
Randy, I have a question.
Yes. Talk
Yeah,
loud.
Okay, yeah. Hello. Yeah, I would like to know, the middleman or the middle person, they cannot produce, right? In order to make a transaction, they need to meet the seller before.
Correct.
Okay, good.
Correct.
Thank you.
Okay. So buyers and middlemen do not trade if the valuation is below some reservation value. That reservation value is endogenous. So when it's high, we said the market is liquid. There's lots of trade going on. But when delta is low, well then, sorry, I said it wrong. When delta is low, there's lots of trade going on. The market's very liquid. When delta's big, then when buyers meet middlemen, they might not trade. They're going to trade with the lower probability. So that would be an illiquid market. This is the liquidity of the market, not of any particular asset.
Randy, if I may ask, and maybe I'm going to say something stupid. Anyhow, I want to say it's nice to see you, Randy. I've been missing you. So,
Thank you. Is this Bruno?
yeah. So I like what you're doing. It sounds very interesting. So you say when delta is high, market liquidity is low.
Right.
I expect that delta will reflect the distribution of pi.
Yes.
So that for the moment, we cannot do comparative statics with pi because basically, if you increase pi, you will also maybe increase delta or something like that, right?
So the distribution of pi is time invariant.
Yeah.
The draws are IID. So we can say you're more likely to trade if pi is bigger. That's just like in labor search. There's a reservation wage, call it R. Whenever you draw a wage above R, you trade. But R is endogenous.
Yes. I agree with you. I was not trying to criticize. I was just trying to say something to see if I was understanding what you were doing.
Yes. Nice to hear from you. Okay. So let me give you some value functions. I don't want to dwell on them. Neil Wallace says you should never put a value function on a slide. Lawrenson says you put nothing but value functions on slides. So it's never clear what to do when your, mentors are in conflict. But I'm going to show some Bellman equations or dynamic programming equations. So the flow value, R times V0, which is the flow value for a middleman without inventory, is alpha, the probability they meet somebody, NS over big N, where big N is the total population in the market. That's the probability the person you meet is a seller. Then there's going to be some surplus from the trade where you're going to acquire the asset as a middleman. So it's delta equals V1 minus V0. and then the middleman gets a share, theta, of that surplus. So theta MS is middleman's bargaining power when they're trading with the seller. And there's going to be some pure rate of time change in the value functions, which can occur for reasons we'll see later, but basically things change over time. You got to account for that. If some people are more conversant with discrete time dynamic programming equations, if you are, well, a nice exercise is to write down the discrete time version, let the length of the period shrink to 0 and derive these. Other people, more or less finance people, this is their native language.
Randy, I have another question, please.
Please.
So NB does not depend on time, but NS depends on time.
Correct.
I did not understand why. Why does NS depend on time?
Okay, we're going to free entry by sellers. So sellers will pay some cost kappa to enter the market. Hence the measure of sellers will be an endogenous choice. The measure of buyers is fixed exogenously. By the way, in the paper, we consider all the different combinations. Could you have entry by sellers, entry by middlemen, entry by consumers? The interesting case is entry by sellers. And if I have time, I'll explain that later in terms of intuition. But NS is going to depend on time. Hence, capital N depends on time because, you know, sellers are part of the overall market population. Okay, moving ahead, the flow value to a middleman with inventory. Well, there's a baseline arrival weight alpha, and B over N is the probability a random meeting is a meeting with a buyer. There's middleman's share of the surplus when middlemen trade with buyers. And this integral is something you would recognize if you did job search. This is the expected gain from trade. It's expected surplus integrating across the random pie.
Randy, sorry to interrupt for a second. That the capital NT, is that going to be bounded in some way?
No, there's going to be,
go-
yeah, it's just like Pistarides with the number of vacancies posted could be anything. We could bound it, not a big deal. But let's think of it for now as, you know, sellers could enter and there's a pool of potential sellers, which is large. That's not critical for what we do. That makes it easier. We don't have to worry about hitting the corner solution. You could do that in Pistarides too, of course. There's a upper bound on the number of vacancies that's posted, but it's usually not done that way. Finishing this equation, middlemen get some return rho from their inventory, which could be positive or negative. Inventory depreciates at rate delta, and there's the pure rate of time change here. Subtracting these, we get a differential equation in delta. So you can subtract them in your head or do it later for homework. This is what you get. Here I integrated by parts, which is a standard trick that you would learn if you talk to Burdett in these kinds of models. Okay, so equilibrium is a collection of time paths. Well, we can reduce the model to two state variables, delta and NT. Delta, I've already explained, it's V1 minus V0, so it's basically middleman's value of holding inventory. N is going to be the fraction of this fraction of middlemen with inventories. So there's two types of middlemen. Some of them have inventory, some of them don't. Little n will be the fraction of middlemen that have inventory. So the total amount of inventory in the population is the number of middlemen times NT. So that Euler equation for the reservation value that I showed you in the previous slide, in combination with the law of motion for inventories, and it's right here, any time path satisfying those two equations constitutes an equilibrium. We need usual side conditions. Paths must be non-negative. They must be bounded. And there's an initial condition for the amount of inventories at date 0. So I'm not going to dwell on this law of motion, but it's obvious. You know, if a middleman trades with a seller, they move from being no inventory to inventory. When they sell to a buyer or get their inventories depreciated, they move in the other direction. Okay, now let's consider the case we were just talking about, seller entry. Okay, now when F is degenerate, so this is like the old paper I did with Ed and Linda, there's going to be some critical value, rho tilde, and another critical value, rho hat. Let me show you the picture instead. Here. The red curves here are the Euler equation for Middlemen in three conditions, rho being the return is high, medium, and low. The black curve is the law of motion for inventories. Notice it as a jump. Why is that? Well, in this model, pi is constant, so all consumers have the same valuation for the object. If delta is bigger than that exogenous pi, they trade. If it's lower, they don't trade. So as this endogenous value of the asset delta moves around, you can have a unique equilibrium down here. I think you can see my pointer, I'm not sure. Down here, there's an equilibrium with a low delta, hence a liquid market, an equilibrium with a high value of delta, an illiquid market, and in between, there's three equilibria. The intuition is what I tried to get at earlier, although this is a special case because pi is degenerate. So I'm not going to dwell on that intuition right now, but I want to dwell on something else. I mean, I will really dwell on it for a second. It's when delta is high, middlemen and buyers do not trade. So M is more likely to have inventory. So there's less seller entry, making it harder for middlemen to get inventory, rationalizing high delta, and vice versa. One thing about this model is when delta is negative, so the inventory has a storage cost rather than delta positive, in which case it has a dividend, you can't have multiplicity. And some people, such as me in earlier papers, said that tells you that asset markets are more likely to have multiplicity than goods markets. The reason you can't have this multiplicity when delta is negative is trivial. A buy and hold strategy is never a good idea when the asset has a zero or negative rate of return.
Randy, I have a question.
Please.
In terms of utilitarian surplus, maybe the equilibria can be ranked?
They can, but it's subtle.
Okay.
It's subtle. So I'm not going to get into that, but we can
Because
talk about it later.
I would have thought that having more liquidity was a good thing, but obviously you're saying I'm wrong. I was wrong.
No, I'm not saying you're wrong. I'm saying it's subtle, which is another way of saying I'm not sure. But I know this literature fairly well, and it's well understood that there could be, just take a generic middleman model. If they have some comparative advantage, say in search costs or search frequency or storage costs, then middlemen actually can promote efficiency. If they're only active because they have high bargaining power, well, the middlemen actually can make the equilibrium worse. So there's no general welfare results in terms of changing parameters. Your question is different. It's comparing steady states. And, I think it's maybe true that this low delta or high liquidity equilibrium is Pareto superior to the other ones, but I'm not 100% sure right now. We could rank them if we just do a bit of work. Now, a problem with this is that it's pretty hard to do dynamics here because of this bang solution for middlemen. If this endogenous delta is below pi, which is just a number with a degenerate distribution, they don't trade. They do trade. If delta gets just a little bit higher, well, now it's above the degenerate value of pi, so they don't trade. So this bang solution is pretty awkward in terms of doing dynamics. So we don't like that. So we're going to go to this non-degenerate F case, and the economics is different. It's not a bang solution. Middlemen and buyers always mutually agree to trade at high pi and agree to not trade at low pi. So they're going to use a reservation value for when to trade. That reservation value can be a smooth function of parameters, and it can be a smooth function of time, allowing us to do dynamics using more powerful methods. In particular, in terms of substance, when you have this multiplicity, when you have this non-degenerate distribution, multiplicity can arise when rho is positive or when rho is negative. Because you see, when rho, in the case where pi was degenerate, the only option the middleman had to trading with a buyer is hold on to the good or asset, which could never be a good idea when it has a negative return. But here it might be. You might turn down trade, you being a middleman, with a consumer because you want to wait for another consumer with a higher value of pi, the higher match-specific value of pi. So this means that even if there's a storage cost of holding the good, the multiplicity emerges, and we have propositions about that, can potentially arise for a row positive or negative. Not a big deal. Okay, here's an example. We did something. We just looked at the degenerate case 2 slides ago, a number of slides ago, and made it non-degenerate by having it like a weighted average of a degenerate case. Because basically we spread the distribution. Now it's hard to see from this, but in fact, the intuition is similar, but this black curve can now be smooth, at least over the relevant range. Ignore that for now. We study local stability. This is kind of standard. The high and low equilibria, if there's multiple high and low steady state, if there's multiple steady states, are both saddle points. And the one in the middle could be, well, it could be a sink or a source. We're going to pursue that. So that's just the proof or the proposition about local stability. Okay, question. Do limit cycles emerge here? Well, we're going to use some mathematics that I learned from my co-authors. Mortensen and Beaudrine and others tried to teach me this over time. I'm slowly beginning to appreciate it. These bifurcation methods are quite interesting. You don't have to know how to prove the implicit function theorem in order to do comparative statics. So a slightly, but just slightly more sophisticated version, you don't need to know all the details of this mathematics to do dynamics. Applying them, at least for relatively, realistic, simple models, is pretty straightforward. There's 3 means of proceeding. There's something called a saddle loop bifurcation. When you can get one of those, it's actually easy and general and relatively beautiful. Hopf bifurcations, well, that's a little more technical. And there's some other stuff which is, in some sense, nesting the others. We're going to work on the first 2 here because that's enough to get what we want. So let me show you how saddle loop bifurcation works. So this is a blown up version of this picture, zooming in around the middle steady state. Here's something beautiful. Mortensen tried to teach me this years ago. So when you have these 3 steady states, I'm going to focus on the middle one and the low one. There's a high one up here. As I say, this middle one could be a sink or a source. So for some values of R, which is the rate of time preference, it's actually a sink, which means the paths head off in this direction, they come back, and they come back below that steady state, and will asymptotically converge to it. For other parameter values, it's actually a source. So starting near the middle steady state, I probably have these 2 flipped. This one looks like a sink. Start again. This picture, the unstable manifold of this middle steady state, it heads off in this direction, and it's going to come in this direction. It looks like it's going to, well, we don't know what's going to happen. But guess what? By continuity, there's a particular value of R, which generates what's called a homoclitic orbit. The unstable manifold of this low steady state heads off in this direction and joins up with the stable manifold. That's a saddle loop. You can see why it's a loop. Now, interestingly, suppose you start off anywhere inside the area encircled by this loop. Well, then orbits can't escape this area because they can't jump over another orbit. So then if the steady state here is a sink, no problem. Orbits starting in this area converge to it. If it's a source, so if it's unstable, orbits starting near it have to move away from it, but they can't escape the region. Hence, there must exist limit cycles. And here's the case. Anywhere in this orbit, we converge. Anywhere in this region, we converge to this blue orbit. If we started in the middle, so the green region, we would spiral out and still converge to this limit. It's a stable limit cycle. Now, that's only true for a set of measure 0 parameters because you have to have the R or whatever your bifurcation parameter happens to be, you have to have it at a particular value to generate this saddle loop. But the theorem in the literature is, even though the existence of a homoclitic orbit happens only for a measure zero set of parameters, for a positive set of parameters, the dynamics is similar. I almost said locally, it's not local, it's global. So you still get the cycles. So the way you do it in this literature, it's not the case that you're always going to get cycles. But for some parameters, if you can construct this homoclinic orbit, and as I say, you try some values of the bifurcation parameter, and then the purple curve is below the blue curve on its way back. For others, it's above it. So by continuity, we know there exists a homoclinic orbit. And then you're done, you know, for a positive set of parameters, there exist orbits which cycle around the steady state.
Randy, I have a question, please. So this is beautiful. I was asking myself, what is the economic intuition? So I think in those cycles, we see that the aggregate inventory of the middleman is going up, and then it's going to go down.
Yep.
Do we have an economic intuition for this?
Yeah.
Mix?
Yeah. I mean, it's the same intuition as the well, I think it's a similar intuition to the multiplicity of steady states. As the inventory distribution is rising, so sellers are going to not enter so much because it's hard for them to, they can still trade to consumers, but they can't trade with middlemen. So sellers are entering at a lower, at a lesser amount when inventories are going up. But then you see inventories start going down because there's fewer sellers in the market. Well, then sellers want to jump in, ride the wave, because they can sell more easily to middlemen. Well, then the inventory distribution starts growing, and then middlemen start dropping out. So it's a self-fulfilling prophecy of the value of the asset delta, and the law of motion for the state variable n that's driving the cycle. Again, for steady state comparison, it's pretty straightforward. If middlemen do not trade with consumers, in steady state, they're going to have lots of inventories. Hence, sellers are reluctant to enter. That makes it hard for middlemen to acquire inventories, rationalizing the decision to not trade very often, and vice versa if you have the other steady state. So the dynamic version is just doing that, you know, not across steady states, but over time. Hopefully that's helpful. And,
Thanks
you know,
a
we
lot,
just happen
Randy.
to
This
draw.
is great.
Okay, thanks. You know, some people think models of multiple equilibria don't make any predictions. I mean, that's not the case. Over our limit cycle, we have, you know, how inventories move and how the value of inventories move. There's like lead lag structures here, consistent with the intuition I was trying to give earlier. The number of sellers in the market can be correlated with delta, with the lead lag structure. Other variables include trading volume varies over time. Output, oh, I see that. I'm reading the labels wrong. Inventories are here, along with delta. Number of sellers are here. Trading volume, total output. This is related to an earlier question. Output goes up in a more liquid market because there's more trade. There's the price middlemen pay sellers and the price they receive from buyers. These things move over the cycle. The markup, which is the selling price divided by the buying price of middlemen, varies over the cycle, and the spread as well. The spread is just the difference between the price middlemen pay and the price they charge.
Randy,
so by the
real
way,
quick, these are beautiful pictures. Is this set up for row being positive or negative?
happens to be for row positive, but
Okay.
we work pretty hard and we find out this can happen for row negative as well.
That's
This is
really
an
good.
example.
So that's even a more general setting. But I gotta say, man, if you could get just a little bit of data to show some of these temporal precedence relationships.
Yeah, we can. We didn't do it in the paper, at least not yet. But, you know, there are things like, okay, inventories are more volatile than output. So, you know, it's hard to tell from eyeballing it, but it kind of looks true. And, you know, we could talk about lead lag structures. Now, this is a point in the presentation where I should add something. I don't think these endogenous dynamics are a good way to understand data in and of themselves. So two things about that. One, I mean, suppose you have stochastic shocks. You're still going to have a tendency like this towards fluctuations that are driven by beliefs, but it's going to be not a deterministic, cycle. It's going to be a stochastic version of that. And by the way, you can do it with sunspots. It doesn't have to be stochastic shocks to fundamentals. But the other, I think, more interesting philosophical position, we don't think that actual data is generated by these low-order continuous time dynamics based on self-fulfilling prophecies. But we think that when simple and I think natural models generate this kind of dynamics endogenously, this lends credence to the view that, maybe markets could have excess volatility or have belief-driven cycles. It's a little bit challenging to get this, but once you know this bifurcation theory, it actually comes out to be pretty straightforward to get this.
Randy, I have another question, if you don't mind.
I don't mind.
Thank you. So you have these very nice changes in inventory, which is great. Do we see, maybe you have already answered that. Do we see changes in price along the inventory path?
Yeah, this is the, let's see, blue again is delta, and the brown or whatever color that is, that's the price that sellers, middlemen pay sellers. This is the price that middlemen charge consumers in brown. And again, here's the markup and spread. So, we have counter-cyclical, actually pro-cyclical markups. When output goes up, looks like markups are going up. Now, by the way, we don't think of this as a macro model. It's a model of a market. So I wouldn't want to take this directly to the macro data, but you might want to take it to some financial data or retail data. These middlemen look like retailers to me.
Because in microstructure, I think they have empirical evidence on the link between inventories and spreads and prices, which might be related to what you're finding.
Yeah, we cite a paper, which I haven't read, but from the abstract, it's clear they talk about that evidence. I forget the authors right now, but in our paper, we cite some people who talk about this evidence. Okay, next slide. Now, this Hop bifurcation, there's two types. So the intuition there is for some values of R, you can use whatever parameter you like. This is a source. For other values, it's a sink. And under a set of conditions that need to be satisfied, you can get cycles around that steady state, even if you can't find this saddle loop. This is more technical and harder to apply, but you either have to just read up on it or get some good co-authors. And we could use this Hop theory as well. And there's two types. It depends on whether, as R increases, it goes from a sink to a source or a source to a sink. Not a big deal. Oh, welfare. This was the answer to Bruno's question. Welfare does not necessarily increase with market liquidity. I forgot about that. So we actually showed that in the paper. I don't have an intuition for it right now. But again, the second bullet point here, that's well known in the literature. Middlemen, they might have some advantages in terms of their fundamentals, but they also just might be good at bargaining, in which case when they enter, that could lead to lower efficiency, lower welfare.
Randy, I have a hunch about the efficiency result. Maybe a market that is too liquid is a market in which you're selling the good to people who have a low value of pi.
I think that's right. I think that's what it is. So, right, sometimes you don't want the good to be sold very often. Don't forget there's a fundamental value to holding inventories. Go back to the Bellman equation. Right, the middlemen with inventories, they get some value row. So in some sense, the planner wants middlemen to hold on to inventories. That's generating output. When they trade it to a consumer, the consumer eats it. So, yeah, thanks, Bruno. I think, if we start combining our intuition, maybe over a bottle of wine, we get some interesting stuff in terms of the...
I like the idea of that.
Okay. Yeah, so that's all I'm going to say about welfare. Let me check the time. I think I go till noon, right? Perfect. Now, okay, what if we change the environment so there's entry by middlemen instead of entry by sellers? Doesn't work. There exists a unique equilibrium. It's a saddle point, so starting from any initial condition, inventories converge to their steady state. The value of the asset is actually equal to its steady state value in steady state and outside of steady state. That's just the same as Pissarides, because you can have vacancies posted as a jump variable at any point in time. The unemployment rate may be away from its steady state, but the value functions of the agents are at the steady state. That's the same here. But you can't get multiplicity. And the dynamics are all saddle point stability. So, it's sort of a unique outcome is predicted. What's the intuition? This is my intuition. I guess I learned it from Rochateau. There's a strategic complementarity in the previous version with entry by sellers. The more sellers who enter, the more middlemen are willing to trade. The more middlemen are willing to trade, more sellers enter. So the two sides of the market are operating in their, strategies of sellers as a positive strategic complementarity with strategy of the other guys on the other side of the market. If middlemen are both choosing their trading strategy and whether to enter the market, it's the same agents who are doing these two decisions, so you don't get this complementarity. So that's kind of a heuristic explanation, by which I mean it's not particularly rigorous, but I find it somewhat compelling. This is not necessarily true in any model you could imagine, but there's lots of models where that's the case. A trading decision by once, for example, in the work with Rochateau, in a monetary model, if consumers bring more money, more sellers enter. If more sellers enter, customers bring more money. That can lead to multiplicity. Whereas in the same model, if you have buyers making the money holding decision and the entry decision, then you do not get that multiplicity. So that's my intuition for why you need entry by sellers to get this interesting stuff and not entry by middlemen. Discrete time. So we could do that. It's tricky. Not that tricky, but we show there was just a 2 cycle, which is an example of, discrete time, continuous time. We have these nice smooth cycles. Here, in discrete time, we have inventories go up, down, up, down, up, down. The reservation value, which was called delta in the previous picture, goes up, down. Yeah, you can get that. And even if you do entry by middlemen, you can get it reduced to a one-dimensional dynamical system, in which case you can get lots of stuff. 2 cycles, chaotic dynamics. So in general, n cycles is a wonderful theorem in the literature that says if you get a 2 cycle, but if you can't get a 2 cycle, you can't get any cycles. If you can get a 3 cycle, then you have cycles of all periodicity, including infinite periodicity, which is chaotic dynamics. This is pretty easy, but we don't like it in the sense that, and Lou has a version of this in a paper with Rochateau as well. This is our version of it. Let H be the length of a period. There exists a strictly positive H lower bar, such that when the length of a period is less than H lower bar, no cycles exist. So here in discrete time, you can get interesting dynamics, but those dynamics are fragile in the sense that as you shrink the period length, they vanish. And this appears in other models and other literatures. Our continuous time dynamics, they don't have that problem. They exist in continuous time. So it's kind of important. This rationalizes why you want to study continuous time models, not only discrete time models, even though the latter can generate interesting and varied results and are relatively easy, but they're not robust. Okay, now for the Keynesian part of the presentation. You don't really need middlemen, it turns out. You can swap out the middleman and instead let consumers make an inventory decision. So when a consumer gets inventory, they can choose to store it for a flow rate of return or eat it You know, like in the Prisoner of War, Radford classic article, you could be trading cigarettes, you got a choice of trading them or smoking them. So suppose consumers, this is what they call in undergraduate macro models or textbooks, the paradox of thrift, I think. If consumers are not consuming very much, so you'd have to have, you know, a really big pie to smoke that cigarette. You really got a nicotine fit. So you're not smoking them very much. Then sellers can similarly make an entry decision. And that complementary works in a similar way, although only for row positive. You can't have only for row positive we show. So the key here that we discovered, it's not the middleman per se. You can get it without middlemen. What we've basically done in this version of mode, we consolidated the middleman and the consumer into one agent. So it's the inventory decision of the consumer / middleman as complementary with the entry decision. I think I said that wrong. It's the savings versus consumption decision of the households, which is complementary to the seller entry decision. That's why I said it's kind of Keynesian. If consumers are not consuming, they're rather hoarding the object being traded, there's going to be less production. If there's less production, consumers are more likely to save, because if you consume something, it's hard to get it back, hard to get it on the market to get another unit. Now, that model's not very elegant. We have to make some assumptions that are not so beautiful to make it work. But the conclusion here, it's not middlemen per se that cause these interesting dynamics. It's the interaction of trading decisions and entry decisions. You can get that without middlemen, but middlemen naturally fit the bill because middlemen have a trading decision and they're also holding inventories.
So maybe in a sense, the intuition is that a buyer with a low pie is someone who is going to hold an inventory.
Right. And how low does pi have to be? There's going to be an endogenous reservation value, and that's the thing that can have multiplicity. So what you say is correct. And you see, you know, I said it was Keynesian because the more consumers are willing to consume, that is have a low reservation value, the more output is the more sellers are going to enter, and these two things feed back in a positive way. Oh, I like these kinds of pictures. This describes steady states. There can be, so gamma is the propensity, the probability of consuming. It's the probability of smoking a cigarette or drinking the wine that you purchased on the, you know, vintage wine market. And there are equilibria where they never drink it. There are equilibria where they always drink it. There's big strategy equilibria. No big deal. We're not that interested in steady states, but you can describe the steady state. This is this is for, I guess, for a degenerate pi. We vary its value and an exogenous value of rho, so no big deal. Oh, conclusion. I'm going to finish early, but I think that's good because I have some general comments. Okay, what do we do here? So why you might find this interesting. One, if you don't know these dynamic tools, they're not that hard. I recommend you try to figure them out. They can be useful. It doesn't work in all models. It doesn't work in Duffy, Garland, or Pedersen. They don't prove this, but Travis and I proved it. There's a unique equilibrium in that model, and it's a saddle point. They do prove the distribution has a steady state and it's stable in the DGP paper, but they don't show the equilibrium as a saddle point. It doesn't happen in Pissarides unless you do something like increasing returns in the matching function, as you know, Diamond has done in many papers, or even increasing returns in the production function, as Mortensen shows in a beautiful IER paper. But without those tricks like increasing returns, you know, it's not that all search and bargaining models generate multiplicity and endogenous dynamics, but some do. And my view of theory is if you write down a model, you should be able to describe the equilibrium set, not just the steady states or some example. You like to know what kind of dynamic equilibria are possible. So these techniques from continuous time dynamical system theory are powerful and not that hard to use. But in terms of substance, it's really the dynamics between consumption strat or trading decisions and entry that's going to hold in a variety of inventory type models. You don't really need middlemen, but middlemen are the obvious way to introduce inventories into a search model. You might notice in Duffy, Garland, Pedersen, middlemen, what they call dealers, hold no inventories. Why? They have access to a frictionless, Walrasian interdealer market. So middlemen will be agents trying to sell the asset, will take it, swap it out in the interdealer market. Agents, middlemen who meet agents who want to buy the asset will acquire assets in the interdealer market. So dealers never hold any inventories. Would it be interesting to do a finance over-the-counter market model with inventories? Yeah, we're actually working on that. It's not so easy, but there are no inventories in the usual OTC. I mean, you could say it differently. You could say, since all agents are holding goods, maybe every agent is holding inventories. In some sense, that's right. But there's no dedicated intermediaries that hold inventories. By the way, some of these papers I don't like. Well, I do like, but they say this. So I bought a house in Philadelphia in 2000. Then I sold it in 2012. Does that make me a middleman in the housing market? Not really. So just the fact that the over-the-counter market models, people are buying assets, later they're selling assets because their preferences were changed. They had a preference shock. Any agent in Duffy, Garland, Pedersen repeatedly buys and sells, but they're not middlemen. And they're set up, the dealers are the obvious middlemen, but again, they don't carry inventories. So I don't really have a good answer to this. Siki and Grace and I are writing a survey on middlemen. We don't have a definition of a middleman. And we say it's kind of like what the Supreme Court said about pornography. Hard to define, but you know it when you see it. So these agents in our model are definitely middlemen. Anyway, I can summarize the results, but let me just mention this bullet point. Although you can get volatility and multiplicity for row positive or negative, it's easier to get multiplicity and volatility when row is bigger. So that means, consistent with this venerable view, intermediation in financial markets is more likely to be volatile or fragile than intermediation in goods markets. I can't emphasize enough that this discrete and continuous time feature is important. There are interesting and easy results in continuous time, but they're not robust. Which is not to say continuous time is obviously better. I don't know what's a more, useful abstraction from reality. It's just to say discrete and continuous time can be different. Okay, now let's talk about search theory in general. Again, I mentioned this before. It may be hard to account for data based purely in these endogenous dynamics. But we have this view that simple natural models can display such outcomes that might make one more inclined to think that actual economies can too. On methods, this is Diamond's original coconut model. This externality, he calls it an externality, it's increasing returns to scale on the meeting technology, involves positive feedback. Increased production for inventory makes trade easier. Easier trade makes production for inventory more profitable, and therefore justifies its increase. This is what gives the multiplicity in Diamond's 82 paper. But he doesn't actually have inventories. Well, let's put it this way. He doesn't have inventories the way we do, but it's similar in spirit. But the key is, once you model inventories, more carefully, or the micro foundations in more detail, you can dispense with increasing returns. Increasing returns is a mechanical way to get multiplicity in dynamics. But once you model the micro foundations more carefully, endogenous trading decisions and entry decisions allow you to get the same kind of outcomes without increasing returns or other, mechanical devices. Of course, Diamond actually had a monetary version of this coconut model where he put a cash in advance constraint in. And again, increasing returns led to multiplicity. Why did he do that? He wanted to think about monetary policy. He didn't know how to get money in the model, so he put it, you're forced to trade your coconut for a seashell and then your seashell for a coconut, by assumption. Well, later work on the micro foundations of money showed you can dispense with the cash in advance constraint in models like Diamond. That's what Kiyotaki and I worked on. You don't need cash in advance to get valued money if you take the micro foundations more seriously. It's the same idea here. You don't need mechanical assumptions like increasing returns to get this inventory dynamics happening. Once you take the micro foundations into account in a more detailed way. And I think that's interesting because money and Middlemen are two related institutions. Bruno, this is for you. Both institutions have raison d'etre. Their justification for existence is the facilitation of exchange, right? That's why there's no role for money or Middlemen in classical general equilibrium. There is a role for both in search theory. One thing that's on the frontier is to have models with both money and Middlemen. There exist a couple of people who have attempted that, but there's a lot more to be done. Because you can start to ask questions like, are money and Middlemen, are they complements or substitutes? Okay, that's the end of my talk, but I'm happy to take any questions in any remaining time or any comments. Perfect ending of exactly 1 hour.
Thank you, Randy.
Thank
we are
you.
going to open for questions right now.
So, Randy.
Hi, Jim.
Hey there.
I recognize your voice.
One could say in some sense that this is a model of random search.
Yes,
So,
it is.
So how do you think things would change if you allowed sellers, when they enter the market, to spend more effort, for example, on locating buyers directly, or more effort to locate Middlemen?
That's an excellent question. Excellent question. Goes against my usual thing. I say it's a good question when I know the answer. Here I don't know the answer, but it's a great question anyway. It's something one could do. One could check. I do know something related. When I worked with Kiyotaki, we had these models. Take the original paper we did back in '89, where there's multiple equilibria with different monies, different objects serving as media of exchange. In work with Courbet and Tempselides, we got rid of random search and put directed search. Then you get a unique equilibrium. So there, in the classic, let's call it classic because it's old, commodity money model, randomness in the matching process was actually critical for getting the multiplicity of monetary equilibria. And it's once you see how it's done, it's pretty straightforward. So our conclusion there, and I think it would apply here, you might need some randomness. So you could endogenize search by search effort, as you say, or maybe with directed search. I think the multiplicity will survive if there's, maybe not perfectly directed search, but I haven't really worked on that yet. Good question, Jim.
Thank
Hey,
you.
Jim, I thought you were retired.
I'm retired from getting paid.
I see. I'm the opposite. I still get paid, but I don't do much work. Other questions?
I have a question, Randy. This is Derek.
Yeah. Hi.
Hi. So I have this view of intermediaries as like an endogenous response to like frictions or
Right.
issues with the functioning of the market. So here, I think that middlemen or even inventories more generally play a role in making opportunities for consumption more readily available, right? They make it more accessible. But
usually, or often, yes.
Yeah. Okay. But in the version with free entry of intermediaries, that's sort of the most. I feel like that's the purest version of what I had in mind, where intermediaries would only arise if they can fulfill that role, and that's the case where it sort of shuts down the interesting dynamics.
Right.
Can you sort of comment on that, I guess?
That's interesting. You see, in the survey I'm doing with Zeke and Grace, we came across this just like on Friday, a couple of days ago, or maybe earlier, but in the basic sort of Rubinstein-Walensky canonical model, if a seller gives a good to a middleman, now there's two goods on the market. Because a seller could produce another one. So you might think that's good because having a middleman, you increase the number of goods on the market. But actually, that's not correct, because if you could replace that middleman with another seller, two sellers would be better than one seller and one middleman. So related to your question, middleman, to get efficiency for a middleman, you need some kind of advantage. I would like to say that, let's go back to some Bellman equations. So, in principle, middlemen could have a higher arrival rate. They're better at meeting consumers than producers are. That gives a reason for middlemen to exist. It's just what you said. It's hard for consumers to meet producers, so middlemen have a role because they're good at search. We can also say they're good at other things, like they have better storage technology. Maybe a lowered, I don't know, we could do a variety of things you can assume about their fundamental abilities. So that's worth investigating further. It's a good comment.
Thanks. Yeah, I think a similar thing to what you're saying is like if you could impose a set of assumptions that would give intermediaries no advantage relative to sellers, they shouldn't play a role in that version either, right? Or
So the classic Rubinstein-Walensky result is if alpha MC, the arrival rate at which middlemen meet consumers, is greater than alpha PC, which is the arrival rate at which producers meet consumers, then middlemen have a role. They're better at search. The general, that's because Rubinstein-Walensky, among other simplifying assumptions, assume equal bargaining power. The generalization is that the arrival rate of middlemen times their bargaining power has to be greater than the arrival rate of producers times their bargaining power. So the better search technology gets middlemen in the market, and that's a good thing. Higher bargaining power gets middlemen in the market with a higher probability. That's kind of a bad thing. So the classic question about whether middlemen, are adding value in the market or just sucking value out by buying low and selling high. Well, in the generalized Rubinstein-Walensky framework, it's pretty clear. It's the combination of two things. Their superior search encourages them to enter, and that's good for the economy. Their high bargaining power encourages entry. That's not necessarily good. Anybody else still there?
Hey, Randy. I think it's a little bit related. Part of the what's generating multiplicity here, I don't think you mentioned too much, but it's like the buyers can absorb any supply, right? So especially for row negative or zero, the big question is how to get goods to the buyers. But like if the buyers get 10 meetings, they consume 10. If they get 20, they consume 20. If they get 1,000, they consume 1,000. There is no negative. So the whole thing is just the middleman and the producers, right? So have you thought about having kind of what would happen like if these consumers were actually getting satiated or
Yeah,
things
that's
like
what led us to consider the inventories without middlemen. That is what you have in mind. That way, a consumer buys a good, they have a choice between consuming it for a one-time gain in utility or storing it for a flow rate of return, like the POW market where you kind of smoke the cigarette or store it. There you were storing it for means of payment reason. Here you could be storing it for its rate of return. So, you get a Lucas tree, right? You can either hold it and eat the fruit every period, or you could chop it down and use it for firewood. So that's a consumer making it, it's what you say. They're satiated when they have a tree because they're only allowed to hold at most one, but that could be generalized as long as the value function was concave, the size of your inventory, their consumers won't be satiated. Once they have a tree, they don't want another one. So we didn't take that model very seriously. We only put in to make a simple point, but you're right. This is all suggesting, as I was saying with the Keynesian interpretation, if consumers get satiated, it makes trade hard. I don't know, I need to think more about that, but it's a good idea to think about that more seriously.
Thanks. So we have time for one last question, if anyone is.
Well, I do have a question. Hi, Randy. This is Benoit from Australia.
Ah, bonjour. Bonsoir
Hello.
to you.
Yeah, it's actually middle of the night. But yeah, actually, this is very, very interesting model. But I'd like to know what would you think of instead of having a middleman, think about a platform, right? Like
Yeah.
Amazon, for example, right? So Amazon
Yeah.
matches sellers with buyers, right?
Yeah.
So I guess your model could be adapted for that.
Yeah, I mean, last time I was in China, Yuzhou and Shenyang Thang were sitting around trying to write a platform model. It seems like a natural thing to do here. We're
Right.
not able to get a good version of it.
Oh, okay.
It's a great idea for future research.
Sure, for sure, yeah.
But we didn't try that long, but we tried to write down some versions that were either tractable and not very interesting, or interesting but intractable.
Yeah, because
One
I don't.
issue. Go ahead.
Well, the main difference here, I guess, the platform facilitates matching between buyers and sellers,
Yeah.
right?
Yeah, you could think of, as you well know, in the directed search literature, there's various interpretations about who posts and who search. You could have
Right.
sellers posting and buyers searching, or vice versa. Or you can have these third parties, which we call, what do we call them? Like market makers. They could post terms of trade and trading probabilities to attract both buyers and sellers to their submarket. That sounds kind of like a platform, doesn't it?
Yeah.
Sort of. Still search within the market, but they are bringing buyers and sellers together. So maybe a competitive search equilibrium version of that would be more interesting.
Yeah.
It brings up something that's quite relevant. There's different kinds of middlemen, right? Duffy, Garland, and Pedersen middlemen don't hold inventories because they have this continuous access to interdealer market. Rubin Samolinsky models, they do. So, used car dealers, they have inventories which are big and costly. Many asset markets, nobody's holding inventory. They're always continuously trading. There are intermediaries, in real estate market. The real estate agents do not buy and sell houses. They simply get buyers and sellers together. So there's dealers and brokers, and there's various types of intermediation going on. Might be hard to get a canonical model encompassing them all. But by the way, banks are intermediaries too, obviously.
Yeah.
They're middlemen between savers and borrowers.
Yep, definitely.
Okay, thank you, everybody. I had a great time doing this.
Okay, thank you everyone for joining. Our next talk, it's Brandon Daly from Johns Hopkins. He will be presenting the importance of being earnest on October 6th at the same time. Okay, thank you very much. Have a good day, everyone.
Bye-bye.
Thank you.
Bye.
Thanks, Randy.
Bye, everybody. Thank you.
Au revoir.